Welcome, I'm Bill Wake. We're here working on a program to compare tunes for similarity. The way we're doing it is with a clustering algorithm and showing the results in a dendrogram. And the idea is you'll select the best matches for you to look at in the dendrogram, and we don't support select yet. So we're going to head towards that this week. All right. I did a couple things. I don't know if I checked them in. I didn't. All right, let me do that. I had these classes in... they were in the wrong folder, so I moved them, and then somewhere, I guess cluster view, I added the accent color, which is our green, to make it look better. So let me check these in. Rearrange folder, update foreground color of cluster view. All right, let's run it. I did run tests, so we'll just run the app. Okay, so we've got no scaling, 39 versions of Deck the Halls, and here's our cluster. Now, it's obvious there's some fine-tuning to do on this drawing because we're drawing our line here inside the node, and we don't want that to happen. Also, we'd really like it to spread out a little more horizontally and make it so that these nodes don't overlap each other any. Okay, but I'm putting that off. These reflect, right now, these reflect the actual computed depth, the computed distance, basically. If we start fiddling with them, it will no longer do that, which may not be a problem in practice, but it is mathematically correct, if not visually correct. So we're going to do some visual corrections later. More important, though, is this notion of selection. So we've got this cluster, and I think what we can see is our algorithm kind of moved all the no scalons close. I don't know if there's, yeah, that one's a little bit related. And that's actually a good sign. It's sort of saying these ones that seem to be the same note-wise also seem to be the same title-wise. So hardly a coincidence. Our best clusters, well, not counting these zeros, I think, well, there's 42. So 43 is our best cluster. All right. And that's this group of 3. And we could select that. The idea being we could select it. All right. You click on the diamond, and basically the subtree to the left gets selected. Now, my idea would be that should be reflected down here. This should be a filtering mechanism, and it's not. We just got things straightened out, I think, on how they draw and where they find things out and improving some performance and that kind of thing. But we haven't done anything on selection, and part of that is selection has a problem. Let's go see it. Okay, so this gets back down to kind of the fundamental model we're using is a pipeline. Let's just open a pipeline. Okay, so for us, a pipeline, it has sources, things that, generate stuff like input files. It has transformations that change the input, and then it has sinks that consume it. I don't know that our sinks could just pass things on as well as consume, but we haven't done it that way. And then the heart of it is here. There's exactly one active source. So to process the pipeline, we run the source and tell it to create something. It creates a packet, and then we consume it by taking the active transforms. One at a time, we're basically applying the transform to the packet, getting a new packet, and repeating that until we have the final packet, and then we send that to the one and only active sink, which consumes it. Now, that's fine. I mean, I think it was a big step to get that together and making sense of things. And when you run it, you can see the result of that, I guess, is what the point is. The ones with curved top of the hamburger bun is a source, and these are sinks, and then in the middle are transforms. So you can only select one sync at a time. Got a radio button there to kind of remind you that. But you can have multiple transforms applied. All right, and so we send stuff through this pipeline. Now, what happens when you change something? Let's make our title contain Galan. Oh, well, let's open a file. Okay, I've only got 8 or so names in here. Okay, if I changed it, now I've got the whole list because I don't have anything restricted. Okay, and so what's happening is this filter stage makes its constraint, and it says, hey everybody, I changed things, and the pipeline rebuilds or reruns. So the file doesn't reopen, but it takes the stuff it loaded from the file, sends that through to the next stage and next stage and next stage. A little inefficient perhaps, but you don't really feel it. Cluster is the only one that's anything like slow, and we got it pretty performant. So it's been an okay solution, but now with cluster, the problem is when it wants to filter it wants well, we don't want to rerun that clustering algorithm again if we don't have to. I mean, if it's a new input file, yes, we need to rerun the output, but if it's the same, then I think we should just say, okay, now just change the filters when they click. Okay, so if they click on a node, we don't want to run the whole pipeline again. We just want to start kind of from there down. Now, I don't know if that's... Well, I'll tell you what I'm thinking, and we'll see how we end up. But well, 2 ways. The easy way, or maybe it's the expedient way, is that I could make stages in the pipeline could annotate. We already passed metadata like, what did you do? You know, I set the title to Galan. We could add an extra annotation like an ID, and the packet going through could say, hey, if I'm not changing anything, I should just send out the same ID. And then the people downstream could look at that ID and say, oh, that looks very familiar. It's the same input. I don't need to change my output. And they can let it go. Okay, so that's kind of one way. The second way is instead of running the whole pipeline again, we could say, if you've changed something, like we manage it more like a list of dependencies. I think of a data flow kind of approach. You know, if something changes in quantize, we don't need to run the previous stages. So we would only start at the stage we change and run the pipeline from there down. You know, anybody who gets affected by it. And some of them might say, oh, I don't care. You know, and others might say, oh, I got to redo my work. All right. I don't know the right way to go here. The second way sounds like more work. I know that. It means when I change stages, I have to kind of, in effect, I want to put listeners in. You know, I kind of want the filter stage to be listening to the file input stage and the quantize to be listening to the filter. And if I rearrange things or I take out one, now I got to take filter off the listening here, take the quantize off the filter, attach the quantize to the input. You know, it's a bunch of handing off, and that sounds prone to error to me. The way we do now, we just rerun that pipeline, and I mean, it's fast. You know, you can't complain about that. So, well, okay. Now, to make things even worse, the way we're doing this, whoops. I wanted to look at that, not close it. Okay, so right now the selection, the selected nodes, is managed by this dendrogram view. So when you select the node, the view updates. It's marked with state, so it knows it's got a dependency. It's got to reflect. Okay, and that changes the highlights. If the node's selected, we do a fatter line, and on the text we bold it somewhere. Well, I thought we did. Oh, that's the diamond. Okay, the text is somewhere else. All right. That all is fine, but I mean, it's good they update off the selection. But the problem is this can be thrown away. Well, no, this wouldn't be thrown away. The dendrogram view itself might be thrown away, but somebody would keep track of the fact that selected elements belong there. But I think, in effect, though, I think it may be the job of the cluster view. I'm sorry, the cluster stage to manage that. Okay, so right now he just knows the transform, and he builds a cluster, but he doesn't do anything. He just returns the input as the packet. Okay, we want that to change. We want this to be filtered. And we also want it to be that if the input changes, then the selection needs to reset. And if the input stays the same, then it doesn't really need to reset. Okay, so I think, now I don't know if anybody else has to work this way. The filter stage. Okay, quantizer. Yeah, I don't think these have, they have state. Okay, so this one knows the selected field in the filter text. Okay, so I guess that's okay. I mean, I guess it's somewhat similar, that those are what controls the output going through. So what I propose to do is move the selection into the stage. So it sort of owns the cluster and the selected nodes, rather than having the dendrogram view manage that. Now, that's going to require some changes. Let's see who references this. Probably just an on-click for there's setup. Is that it? No. Oh, where's the click? On tap. Oh, this is it. Yeah. So when you tap, why is that not here? Oh, there it is. Okay. When you tap on a diamond, it says, oh, that diamond, the node that corresponds to that in the connector, has a list of all the node and its children, and let's make that the selection. Okay, so let's get their task on here. All right, so make the selected node pass through the filter. Well, I think the first step of that is going to be making the stage know the selected nodes. Okay, so yeah, updating the stage updates the initial selection, right? Okay, so if we're going to do that, let's see. We need to pull them from the view. Okay, so let's take this, that, okay. There are the selected elements starting out empty. We don't need state, we really want published and public. Okay, so this stage will keep track of that selection. Now we need to initialize it. We do that in dendrogram view in the constructor. Okay, so well, we've got the cluster. I guess that is it. So this is going through and finding, basically it's finding which ones to highlight initially. Okay, so we'll pull this over here. Now, I think that's going to be here. And, okay, so selected elements equals, well, we don't need this overhead now. Okay, so we're starting with, let's see, we got the cluster. And let me look in that thing. Cluster, okay, has the elements. All right. I'm not sure where the connectors are just being created at a later time. That might belong over here too. All right, but in any case, we're doing something to find, well, we're finding the first node, which is always the best node, the best match, or at least tied for it, and taking it and its children, in effect. Okay. Let's see, what else do we have to do? Well, let's see if we can, I guess I'd like to first make this work. I'm going to close this because I keep going there. I want to make it work. I don't want to worry about the action just yet. Draw elements. Selected elements contains. Okay. Right. So we're going to instead of going to selected elements, we're going to ask state for its the stage for its selected elements. Okay, so let's find usages. I'll just comment it out for a moment. Should get some red bars telling me where everything is. Okay, so this stuff is really irrelevant at this point. We're not managing it. Somebody else is. Okay. Let's take stage dot contains. I think I can do that. Okay, and now I'm seeing this, what they call it, train wreck, law of Demeter violation. This dot this dot this. Okay, we could just ask the stage, does your selection contain this? All right, we'll try and get it working first. All right, so stage already gets set up. Okay, and cluster is set up. I don't know if we need to look at that either, but let's see what happens. And I don't have a formal refactoring for this. It's something you got to do once in a while, though. I should probably pay more attention to it and see. Okay. Whoa. Hey. All right. Oh, but yeah, we have a selection. Oh, and I can't click yet. Okay. That's reasonable enough. Okay. So 39, I guess, is our best match, which is true if you look at these. And it's got those three selected. So that's a very good sign. Okay, let's take some of this out. And where's that action? Oh, that did not work. Let's check that again. I imagine there may be a synchronization problem. Okay, now cluster. All right, that's there. Let's break here. Am I allowed to do that here? Sure enough. Okay, stage. Well, let's print stage.selectedElements. 38039. Why it's in two places, I don't know. All right, and if I step over, let's print connector.element IDs. Okay. And this, and it's those things. Okay. Let's make the stage explicitly do that. Okay, so public void set selection, and that's going to do this selection step wherever we got off to. Okay. Well, element IDs is an array event, set event. Okay. Equals number. Okay. So equals new selection. The reason I'm pulling it back is I want to make sure the publishing mechanism gets involved. I don't know if that's golly. I don't know if that's a problem with this, but it didn't update, so something's suspicious. Let's continue. Did I close that? No. Okay, so that didn't update. Let's take this break out. Continue. Right, okay. And we'll need to call that as well. So set selection. We'll take the small file while we're doing this. Okay. That needs to be updated. So just private variable, I think it's only going to be set and it's not going to be listening for changes. So I think he needs to be observed object. Private is fine. All right. And self.stage equals stage passed into us. Okay. Let's see if that's better. And where are you complaining? In cluster, okay. Well, let's continue. Okay. Take that breakpoint out. Am I running? Okay, let's All right, let's do it again. Seems more promising though. We'll do the big one just to make sure. More opportunities there. All right. So this cluster. Then we go back. All right. And all right, so I think we've moved selection from view to stage. Now this, who's using that? Cluster. Okay, we call build connectors. That almost seems like we should be getting it from the stage every time. All right, we have it there. Let's do that. Let's take this one out. Okay, so it gets its drawing stuff from this cluster, so I'm pretty sure we're in good shape. All right. Remove cluster from dendrogram view. Reference the one in the stage instead. Okay, I think that's good. Make stage know the selected elements. Right. It updates the initial selection. Okay, so we've done that. I guess I also move files to right folder. That was off camera, but this was on. Make selected nodes pass through the filter. Okay, now it's where it's going to get challenging. So you've selected these. All that happens is we draw them differently. In here, let's see. Yeah, so if stage selected element contains, let's fix that. We mentioned it before. So stage.selectedElement.contains, this is a sequence number. I want to just ask, is selected sequence number? All right, so let's add that. This returns a Boolean, which is sometimes not a good thing to return, but I think in this case, the information is being used for UI, so it's kind of supporting that. All right, and we're just going to return selected elements dot contains that. Okay. Now here, Okay, stage dot is selected. Stage dot is selected. Okay, so now, well, this is published, but nobody really needs to access it. They're accessing its information here. I think that's okay. Publish says if this changes, update the object. Okay. I don't know. I could probably make it private, but I don't think there's a harm in asking about it. All right. Let me run tests. Let's move this down a little so we can grab it a little easier. Okay. Open file. Grab this one. Cluster it. Right. Okay. Okay, now the trickiness. All right. The deal is, okay, when somebody changes the selection, I want to tell the world things have changed, and I want, in particular, I should be only passing stuff through that matches selected nodes. Transform. Tell you what, let's make a little helper for this mess. Well, would that Xcode help me? Yes. Okay. This is set initial selection. Okay. Now, okay. Yeah, here's the problem in a nutshell. We want to set that initial selection, but we kind of only want to do it if the packet has changed. All right, so if the packet is unchanged, then we just want to apply the selection. Okay. So I think what I'm saying is packet should have this identity, and every stage should be responsible for paying attention to when that identity has changed. Now, many stages don't care, but I think I can. I don't want to hold the packet. Do I? I don't know. All right. Will it help to add an ID to the packet? Yes, but then he's got to be responsible to dig in and change it. So what happens is the first time through, it should come through and do this stuff it has here. Then the person selects. Well, when they change a selection, we need to trigger a change in the pipeline, I think. Okay. We do that in most cases. So here's filter stage. Where are you? Okay. Transform. I guess the difference is the filter text doesn't change if you change your inputs and stuff, so it doesn't care. But who owns the editing of this field, right? That's got to be the filter view. Let's go see that thing. Filter view. It should be sorted. All right. When the text field happens, this marks settings changed, which triggers the pipeline to rerun. Okay, so from a to-do point of view, make selected nodes pass through. Let's make packet be identifiable. I guess I can capitalize that. And then we need to make well, we need to make ClusterStage track the packet's ID and reset selected nodes when it changes. Okay. Well, packet identifiable, that's a doable thing. Oh, let's make sure everybody's happy. Okay, and then the difference here, this thing, okay, all right, let's go to packet. Well, let's make it identifiable. All right, it should offer to create an ID. Let's just make this UUID. Okay. So, really? Okay, so now every packet is identifiable. That should not affect anybody at this point. We may need somebody who knows about it, but all right. I don't have a packet test. I don't have a packet test per se. Okay. Let's kill that. All right. So the way packet ID is now, well, let's go to the file input. That's a source. Okay, he returns packet. let's go to input view. All right. So input view ties into that source, and he's got a file importer. All right. And the file importer handle result. Let's see what that does. Okay, file input stage. All right, so when somebody opens a file, what happens? Well, this thing tries to parse it. Okay, and parsing it, it takes the string, finds the file basically. Okay, and in the end, well, where's the call to parse? I guess create parser.find tunes. Okay, so it's got the input, path and file name. Okay, so create takes, let's see where a path and file name set. Okay, here they are. All right, so basically if the selection dialog comes up with something legit, it sets the input, the path, the file name, and the errors. And that sets this. And then when they call create, so first you're calling open, open the thing, and then you're calling create, which populates the pipeline. And the pipeline is going to take whatever input and whatever path it already has established. And that's the kind of thing we're going to do too. All right, so it creates a packet. Now, okay, this is the tricky one. So this will create a brand new thing every time the pipeline runs. Okay, which is probably a mistake from our point of view. I think it should know that ID. Let's see. Because right now, this gets run every time the pipeline runs, but we might run the pipeline every time we change a character in a filter, say, or click on our diamonds would do it. And they're going to force a new parse and a new packet and all that stuff. It's a little odd. I mean, I could almost see all this stuff being in handle result. Like create the parser and the tunes when you succeed here, and otherwise don't. Okay, so I think because this creates a new one every time, that's a problem. So let's figure out what our tests are for this. FileInputStage test. File test. File stage. Nope. Filter stage. No, filter stage. Okay, do I not have a file input? We don't really have a test for this. That's odd. It's all kind of UI driven. File input tests. Okay, that's the thing I want. Okay. Let's make this file input stage tests. Should I rename the file? Yes. Okay. So noses statistics input path. All right. So I guess what I'm saying is I almost want handle result to take care of all this stuff. Maybe it takes care of everything and just creates a packet and then leaves the packet around. And if somebody changes something, create doesn't change anything. It's only if the file changes, if we've called this. All right. So, well, I guess what I'm trying to say is if I call this thing, if I call create, and then I call create again, I should get the same packet back, including ID. All right. Now, is that going to be true? Well, let's see. We have create. No static information. Good. Writes tunes and file name to packet. Yes. Okay. Store starts with no errors. That's a good thing. Transform with no errors. That doesn't quite. Source.input. Oh no, that's a file input. Source.errors.count. Why is that? Well, I guess that's a legitimate thing, so it shouldn't have any errors. Transform is the right word. Each create. File errors reported. Okay. The file ready URL. Test. Finds error when reading file. Okay. How about when file is missing? That seems to be what it's really testing. Okay. So I think the interesting thing here is this one that has two creates. Each create resets errors. Okay, I think we want to, let's see, test with no intervening file load, return same packet. Okay, so we'll do this. Let's do that. Source.create, and then if we source.create, we want to assert, well, we want to assert they're equal, really, packet 2. Okay, and I don't know if we have equality. We're not equatable, so we need a file input source. Okay, source equals file input stage. Yes, does not convert to equatable. Okay. Okay, now this test should fail because it comes back with two different IDs. Okay. Okay. I think to some extent that captures what we want here. All right. Now, making this happen, I think I hate to pass data across these functions, but I'm going to do that. We're already doing it in effect. I don't know where errors is. I guess source must have those. Yes. Okay. All right. So input file path. Input. They're setting up input here. Okay. So I think what I'm saying is these three things should happen on handle result. If I move them there, I'm going to break these other tests, though, I'm afraid. So I think I want this to happen. And then I need packet. Empty packet. I don't know if I can do an empty one. No. Okay, I don't care about that one too much. He's still not happy. Okay. Now, I need to do packet as well. Okay, so I find the body, mark that as my input, save the path, save the file name. Okay, and that's All right. And pull out any errors and then build the packet. All right. And then I think in here, I'm just going to return the packet that we already built. And I'll comment this out. It may take some work to get this going. Okay. So let's see the file input stage test. Now, I think the one we just added should pass. I think some of the others will fail, but probably not all of them. And I don't know if we're calling handle result anywhere. Yeah, we are. Okay. Boom. All right. Where are we? Okay. That one's fine. This one, he's assuming. Oh, dear. He's assuming he can just shove some input in, lie about the path, and call create. Okay. All right, let's go on. This one may be okay. This one should blow up. Oh, okay. Okay, didn't parse, so it didn't find any errors. Each create resets errors. That's not really true. Okay, what about this one? Yeah, so we got that one working. This is a handle result, so I expect that to work. Same thing here. Okay, but mostly we're going to have to call handle result. Result. Okay, we got to make one. All right. Yeah. All right, so that's a little different. Input is coming from body. Well, you know what I could do? I think maybe this needs to come out. Let's pull that out. Make packet. Okay. Now I'm going to make this thing return the packet. Okay, and here returns packet. All right, parser, he's got a side effect. I won't do the assignment. Right. Okay. Let's see how they do now. Well, this one doesn't have a chance. Do I want to let it do make packet? I think I will. Make packet. I want to pass in input. Make packet body, and this should take input of string. Okay, so now you're calling make packet with input. Is the path being set elsewhere? Yeah, okay. Let's see if that works. Well, not while I got a. Oh, it's a failing test. Okay. All right. Let's run the package again. We should get a little further. Yeah. Okay. Now parse. We're calling create. Well, we're really going to need to do this kind of thing again. I guess we don't need that input. It's coming in source.input. Okay. Make packet. Boy. Input comes in. Okay. I guess it's tolerable. All right. Source dot make packet. I don't even care about that. Let's just do this. All right. Now, the others are okay. All right. So it's just this one. And this is the one I think is problematic as we are. Okay. So what I want to say is make packet. Of this input. Okay, he should have an error. And then if I make packet with this input, the error should go away. Okay. Each create. Well, okay, I think that's accurate. We open our input, we make a bad packet, we check that the error count is 1, and then we make a good packet and check that the error count is now 0. Okay. Source.input. I think I need to handle result here. Well, no, it is create I'm doing. But I think I need to do this. Okay. So that's that. All right. So I'm saying now if you make a packet as if it had been read by input from an input file and you call create, you get a packet back. You call create again without reloading anything, you get another packet back, and they should be the same. All right. I wonder if this is redundant. No, it's not. Okay. Let's run this subset first. And then run everything. Okay, so what we make input stage, well, file input, only return a new packet if the source has changed. Okay, we did that. Okay, so I would say we also make file input stage produce a new packet only if the source has changed. Okay, and that should run the same. Okay, that's looking good. Let's open up a different file. Miss ABC, 5 files, 5 tunes. Okay. All right. I think this is a good time for a break. We'll come back and we'll focus on ClusterStage, although we have to make everybody do this. Well, I guess right now everybody's creating new packets all the time, so they don't have this problem. Okay, we'll see, but everybody's going to have to consider it, I guess. All right, so we'll take 3 or 4 minutes and come back and tackle ClusterStage. Welcome back. All right, let's take care of this. ClusterStage, track the packet ID and reset when it changes. All righty, here's ClusterStage. So the problem I have is when the packet is the same, we go through and do all this work again. And that's really unfortunate. Let's find his tests. Okay, not much here. All right, no cluster before any transform. Yeah, that's true. Has a cluster after the transform. Okay, well, let's get this. So, how about retain selection if packet if transforming the same packet. Okay. Well, we'll need a stage and a tune. Something like all this. Let's see. Stage, yes. Tune, yes. We don't care what it is. We just want to make sure. Do we care? Well, it's kind of weird if it's clustered. Okay. Can we tell? Maybe we can force it to take a selection. Okay. I guess we could. It's a little artificial, but we'll do it. Stage.selection, selected elements equals, let's say, 2, 1, 0. All right. So now when we call transform, well, we want the same packet. Let's pull this variable out. Excuse me. Packet. Okay. If we call transform of packet, all right, I guess if we call transform twice with the same package, what do we notice? I guess our stage.selectedElements should not change. It's a little weird to me. Okay, let's see if this will go. Okay, we create a stage. We create a tune to put in the packet. Whoops. We set selected elements. Then we call stage transform twice, and we want to make sure the selected elements did not get reset. Now, I think we may not be working correctly anyways, but this should fail. Oh, that was supposed to be assert equal. It's going to pass. Right. Okay. Yes, that one will pass, but because we're just returning the packet in our transform, wherever that got off to. Oh no, we're not. Okay. It's something about the initial selection. If the cluster's not nil, well, all right, we're missing a test. Probably. Okay. Let's check initial selection is empty. Okay, so we're going to call we only have one node. Excuse me. So ClusterStage, like, see here, if there's no best match, in other words, the leaves.count is not in the cluster, we should reset selected elements. So I want to make that true. Okay, so cluster exists. Which I think it must at this point. Does this return? Oh, if it's empty, return nil. Okay. Yeah. All right. At this point, well, if matrix count equals 1, see, I don't know if I've dealt with these corner cases or not. Counts greater than 1. No, it's not. There's only one thing in it. We return it. Okay. So that's going to return a cluster. All right. Yeah, I think... where's my cluster tests? There we go. Okay. With this, I'm not going to set this initially. I'm not going to... am I going to transform? This might maybe be 0. I think it's empty. Should be empty, I think. There's no... yeah. I don't think it makes any sense to select a node if there's only one entry in the thing. Okay. All right, so create a stage, create a tune, put the tune in the packet, run the transform. This is the first time we've seen this packet, so it should do whatever it does and create a list of empty selection. It's not because it's empty, though. I mean, that's correct in a sense. ClusterStage starts with this empty, which it should. And he's calling set initial selection and it stays empty. Okay, that seems good. All right, now what was the second stage of this? Initial selection retains selection if transforming the same packet. That is true, but we probably need the other case first. Resets selection if transforming a new packet. I don't know if I can do this with one tune. Okay. Tune. Yeah, I don't know. Hi, welcome. So what we're doing is a program to take different musical tunes and compare them for similarity. So I'll run it once since you're new. Always try and do that. We're trying to compare them so we can see which one's the most alike and manipulate them based on that. So this is 39 versions of Deck the Halls, known as Nos Galan. And we get this, what's called the Parsons code is sort of Well, it's going down, down, down when the song goes down, but it doesn't tell you it goes down one step. So it's I think of it as a derivative kind of thing. This is the general shape of it, though. Mostly down, da, 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 da. It goes up a little bit. And you can see a lot of these versions are similar that way. This is a very primitive grouping because it just sorts them. I almost should just put them in the same order, maybe would be as good. But you can see that based on the shapes, these two look very similar, 32 and 35. All right. And these are suggestively similar too. They might be identical. Then you get some that are just clearly like this one's going all downs and this one's going across. And, this is more like our originals. So there's variety. All right, we're adding this thing called a cluster, and we're going to try and group these things in a way to tell us which ones are the most similar. So 1 and 39, they're basically identical and they're very similar. 22 is probably the closest to that. Oh, actually, 32, 35 with 34 here, that cluster is pretty similar. The idea is we select these things based on the group we want to look at. So we might want to look at this group, or maybe this group. They're similar to each other, but not that similar to the whole set. And same for these. Okay, so we get this kind of picture where the length of the tree or the bracket, a longer one. The closer they are, the more similar. So these two are basically identical, and these are moderately close, and this one's way far away. Okay, what we're trying to get though is I would like it when you select. I would just want to get the nodes that I've selected. So I'd like to see 15 and 37. Well, I've still got everything. Okay, and up till this point, we just have been recalculating the pipeline when something changes, but this clustering algorithm is a little tiny bit slow, and we kind of want to know when are we looking at the same stuff, and if we are, then we don't want to redo the work on that. We just want to change the selection. All right, so that's where I'm working on now, and what I'm trying to do is let me look at the pipeline again. Pipeline body. Okay. The pipeline is we got some inputs, some transformations, and some syncs. So in this one, open a file, that's an input. Clustering is a transformation, and then the Parsons code is a sync. So yeah, so this is strictly from one note to the next. Are you higher or lower? And you can have repeats like kind of in the middle here. Star is just the opening, and then down, 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 repeat, up, down. Okay. And it gives you, it doesn't mean they could be going down, but by different amounts. This one could be going dum, bum, bum. Okay. But that looks like 3 notes going down. Okay. Just like it does da, 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 so it's just giving you kind of a hint that they're similar, but the front of this one looks awfully much like the front of that one. I think it very likely they're a similar song, whereas this one that's like down, 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 down. I don't think it's probably the same song. It might be closer to this one. But if you're given a bunch of these songs, I mean, this is, I'm working with a musicologist, I guess you'd say, that's collecting versions of Deck the Halls or Nos Galan, and which was originally a Welsh New Year's song. Okay, and I've got the set of 39. I think she's up to about 50 or 60 now, different versions she's collected. Some of them make sense, some of them don't. Lots of times the lyrics aren't related, but the tune is, and things like that. Okay, so the goal of this program is to help her so that she can say, gee, I see some of these seem to be pretty similar. Let's look at the actual tune and see how close they are. Or let's look at the Parsons code and see if they look that close. Let's see, what do we got? 34, 35 are pretty close, supposedly. Here's 34. Here's 35. Yeah. Okay. It's similar, but there's a little bit going down in this one that didn't happen in this one, but it's close enough that you might be interested. Another tool we've added is quantize, and quantize let's see. Sorry, okay. So quantize, I'm saying don't just look at every little note, because some of them could be little twiddly little grace notes of some sort. This says group them by quarter notes. Okay. And so tunes that are more similar may pop out a little more based on that. Okay. So here's 40. All right. 139 and 22. Okay. You can see where this order isn't helping any. Here's 1. Little mountain range. 39, very close. And then 22. Where are you? Yeah, I'm sure it's in here somewhere. All right. Oh, yeah, there you go. So 22 versus 1, there's definitely similarities, especially up till kind of the mountain peak. This one goes down a little slower and stuff, but that's there, you know, compared to trying to read 39 pieces of sheet music and go like, yeah, I remember number 27 sounded a lot like 22, you know, that kind of thing. This is trying to help you shortcut that process and get the ones that are really likely to sound the same, get them together and analyzed. All right. So the pipeline, when you change the filters, like I added that quantize, we have sources, transforms, and sinks. So it's just a normal pipeline that way. The process is it puts packets through. So it creates one from the single source, runs them through each transform on each of those transforms, and then runs the final consume on the sync. So it's just doing that in the pipeline. All right. And we're going to, we're changing it around a little bit. Okay. So before, yeah, it's different. Yeah, I'm learning a lot doing it too. There's another one we did. I can show, let's see. This also takes a second or so to load up, the melody average. So this one takes all those versions and it's going to try and guess, like on the first note, like how many different first notes are there? Well, 12 out of 39 start on the fifth note of the scale, and 10 of them start on the first note. That's 22 out of 39. That's a good majority. Second note, a little more spread. Third note, most of them are here. Fourth note, looks like some of them don't have a fourth note. Okay. But we can get kind of sort of like taking the average tune, the most common, version of this tune. So deck the halls with boughs of holly. You can almost see it coming out of there. But it's just got the spread, and you can see like there's a lot of spread, but admittedly there's only one or two below it, and they're kind of in there. Okay. It gives you some sense of how much there is. Like this one where it's 14, 6, 4, 2, 2, 3, that's kind of a lot of spread on that. This one, 2 10s kind of cover the bulk of it, and we can go from there. So different tools. I mean, I don't know, I had it printed out somewhere, but this musicologist, I've got one of his, he's got a set of 4 books but it's like, here are 200 versions of Barbara Allen, and, with the tunes for them. And, if you've got 200 versions, I don't know. It reminds me of house shopping. You go and you look at houses for 3 days, and by the end, you can't remember any house from any other. I can't imagine doing this with 200 tunes without some sort of tool to help you do the analysis. Now, the first versions of this were done by hand. Somebody sat down and just tabulated all these things. We get to do it a lot easier when we do it with the computer involved. But it's interesting how much variation there is in these tunes that are supposedly the same tune. So, I'm definitely excited to help explore that. All right. So what I'm going to do is work on this thing of selecting. So when I select these 7 tunes, I get, let's do Parsons. I want to see 7 tunes down here, not all 40. Okay. I'm also thinking maybe these things would be better in numeric order down here now. I don't know. I'm sorting them by their Parsons code, So down, 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 you know, all the ones that start down, 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 down show up first, then the DRs, then the DUs. It doesn't really tell you if you slid things around, would they fit better and stuff like that. So we have opportunities still. Okay. Now pipeline cluster stage. So what we're looking at with this test is we're trying to add the idea that if you don't change the input, you shouldn't need to recalculate the output. Okay. Now in this case, excuse me, we're trying to monitor, we're keeping track of the selection because we do want to change things if the selection changes. But if the same packet feeds in twice in a row, it should be the same selection at the end. Now this one, okay, that's fine. But, oh, wait, I'm trying to make a new one. If transforming a new packet. So this one, we're trying to create a new packet. So let's do that. Okay. And I don't need stage again. All right. So let's get tune 1. Okay. And then tune 2. Packet 1, packet 2. Okay. I'm not going to set selected elements. Okay. So this one, where's tune 2? Okay. So this test, we send the same packet through twice. This test, we're transforming a new packet. So we built a tune. Actually, it doesn't even matter if they're contents. It's an empty tune, basically, but it is a tune. We make a new packet. Actually, can I get by with tune 1? I think I can. Okay. So I guess we can just call it tune. Okay. We build a packet, we set the selected elements, we transform the packet, then we're building a second packet, transforming again, and these should be reset. Okay, they should be empty. Well, let's see. I think I want this in here. Okay, let's try this. Create a stage, create a tune, create a packet. Run the packet through the transform. Okay, that's kind of one block of activity. All right, then we're going to change the selected elements. This is so we can tell that it's changed or not. Okay, so we change the selected elements, and then we're going to run. Oh, I got too much here. Sorry. Okay. Cluster 1, we put tune in with packet 1, transform it. Change the selected elements, run this packet through, this new packet through the transformation again, and it should have reset those. Okay, so yeah, that I think, oh, okay, well, no, they're not network packets. They're my invented packet. It's got the tunes and it's got the metadata, which is like, I opened this file, I modified the quarter notes, kind of all the transformations it's doing. Okay. Yeah. So Swift's a lot like, it's enough like Java. I mean, from an OO perspective, there's a few little twiddles that are different, but, it's in that general class of object-oriented languages. Okay. All right. So we got a tune. We reset the elements. We run the tune, and it should change those the selected elements. All right. And this, I believe, will fail. One of these three should fail for sure. Otherwise, we're not doing something right. Okay. This one fails. Okay. Let's run the whole class. Make sure just that one fails. Okay. Good. All right. Now, ClusterStage. Okay. So basically, if the packet, we basically need to keep track of that packet's ID. Okay. So let's say saved ID, private var saved ID, and we'll just start it off with a UUID so we know it's different. Okay. What I want to happen is if the saved ID is the same, I don't want to do any of this stuff. I only want to do it if it's different. Okay, so if saved ID is not equal to input ID, then we need to reset all this stuff. Otherwise, we're returning input. Okay, I think that's correct. If it is input ID, if it is the same, we're just going to do what we always do. Okay. They all should pass. Ooh, I saw a failure. Okay. Does not reset. Okay, well, yeah, so this is, if the cluster's not nil, I think we want to start this off empty. Okay, so cluster not nil means we actually do have something we're working on. Okay, and this stuff is if the cluster really has, you know, a best match element and stuff, but that doesn't apply to us. We do want to reset it no matter what. Okay, so let's run these again. Oh no. Is that same one? Oh, it's a different one. Okay. Okay, this could be relevant. Okay. Yeah, I think our test, we kind of need to do the same thing in the test as the other one. Do the transform, which resets it, make our selected elements, and then transform again. The selected element should not be touched. Okay. It's hard when your tests are wrong. Pretty hard to get the code right. Oh, man. Okay. Oh. No, it should not touch it. Well, let's go in here. Oh, I didn't save my ID. Okay, let's try that again. You can talk yourself out of anything. All right. Let's make sure that was all tests. That was very fast. Yeah, 300 tests. Okay. All right. Now, so make a cluster not recompute if it's processing the same packet. Okay. Now, I don't know what we're going to do. ClusterStage. Okay. Yeah. So we're tracking the packet's ID. Reset selected nodes when it changes. Yes, that's true. Okay. So we're doing that. All right. So now we want to make it so selection actually does something. All right. Oh dear. What's the deal? We may struggle to find things. Okay, that'll be interesting. Okay, so ClusterStage, when you're running this thing, you've got those diamonds you're clicking on, and they should capture the tunes that are involved. I'll do the short file just to get the demo. All right, so there's 2 versions of Old Joe Clark, 2 versions of something pretty unrelated, similar to each other, and then something really unrelated. Okay. If I select 6, I only want to see 3 tunes in the output. All right. The problem is these numbers, 7, 8, they are not the same as these numbers. Okay. These are kind of the title of the tune or something. All right. I don't know. We're going to have to see what information there is. Okay, I'm going to go look at the clustering because it doesn't know. Somebody knows. All right. So mostly what happens is, let's see, can I find that? Let's see if we can find a Wikipedia article on it. Yeah. Here we go. Okay. Bottom up. All right. This is, no. Complete linkage clustering, I think. No. We're doing single. Okay. Yeah, this is the algorithm we do. So what happens is, you can see it from this picture the best. It's going through and it says, I've got all these nodes, and it just builds a matrix and it says, how similar is each one to the other one? So there's no distance from A to itself, B to A is 17, and so on. And then it starts and it says, okay, what's the smallest value? Well, 17, so let's cluster A and B together. And it builds a cluster from them and then kind of recomputes the table. Okay, now the distance from AB to C and to E is both 21, so those can be in the same cluster. And then finally, there's one node left, and it puts those, and then that's the dendrogram we're getting. When we draw ours, we put the names of the songs, so I know we can get to it, but the algorithm doesn't care about them at all. It just assigns the inputs a number, 0 through n minus 1, I guess, and goes from there. So I know that when we're doing the clustering, we know which one we got. Okay, so this is element. Let's see who uses this. All right, proximity matrix used by ClusterStage. Okay, and the function is tune.distance, and the input is tune.tunes. Okay, and tunes is basically an array of tune. Okay. So ClusterStage, what he's got is in the clusters, he's got the node numbers of the clustered items. Okay. And we want to get back to the values. So where's cluster? All right. So we have a cluster of tunes, and we get matrix.clustered. Oh, I think the sequence number is the same. Okay, this is good. When you make this thing in the first place, we run through the elements. So that's the array of tunes, and each one gets the next number, 0 through n. All right, so that should correspond to our array, and everything will be easy, I hope. Okay, so we need to, I guess when somebody, I'm going to have to create some tunes here, I think. Okay. Selected elements. Okay, I think we can do this. So test what do we want to know? I guess it only sends selected nodes through. All right. Now, I feel like we're going to have to make a number of tunes to make this hang together. Yeah, maybe we can do it that. Okay, let's create 4 tunes. Okay. Trying to think who's got the best chance of creating a bunch of tunes for us that we can steal the approach. Average tune, that might. No. Note tabulator. Okay. Yeah, we can do this. Create G. No, we have a helper somewhere. Where is that thing? Create notes of string. Well, that only creates 1 tune. Input notes.map. Oh no, it creates multiple. Okay. Yeah, so we can use abc parser.create. All right. We got a tune. Let tunes equals abc parser.create. And then we pass an array. So let's do ABC, ABD. Let's do another C. Let's do this. D, ABC, AB. Well, let's CDE. I'm trying not to deal with the octaves. CDF. Oh, let's make it go down. CDC. CDE. CDCAB. Okay, so I've got 2 identical ones that should show up the same, and then I've got one that's the same length and slightly different at the end, and then one that's longer. Okay, so 0 and 2 should cluster first, then 1, then 3. All right. So if we pass that in, tunes is tunes. Okay. I think I could say ignored is pretty well true here. Okay, we transform the packet. Tunes. Transform the packet, and then if I select well, 0, 1, 2 should be selected initially. Okay, so I'm gonna say let's get the output is stage.transform. Okay. Output dot tunes dot count. That should be that should be 3. Okay, because the cluster by default, it's going to take the 2 best tunes and cluster them, and that'll be nodes 0, 1, 2. All right. Now if I change that 0, 1, 2, 3, let's change the selection. Equals wait, 0, 1, 2 is only going to be 2. Okay. It's not 0, 1, 2. It's the count. 1, 0, well, there's 4 here. So this is 0, 1, 2, 3. The first cluster will be number 4, connecting CDE to CDE. Okay, and so there should only be 2 actual nodes in there, tunes in there. Okay, if we modify collection and I take 0, 0, 1, 2, 3. No. I just want to take. Okay, that's 4. 5. We'll pull these 2 in. Okay. 0, 1, 2, 4, and 5. Okay. I should be selecting the first 3. Let's put this in front. If I'm not going to select it, I want to make sure it's in the way. Okay. In any case, this transform will still find the 2 best matches CDE. Okay. So the count is 2. 0, 1, 2, 3, 4, and then 5. Sorry. 1, 2, 3, 4, 5. So 1, 2, and 3. 4 is their join, 5 is their join. Okay. And I expect the count is going to be 3 now. Okay. So these 3 will be connected. Okay. This will not work. Okay. I think it'll be 4 and 4. Yep. Because it's not doing any filtering. It's just sending those 3 things through. All right. Now we can do it. Okay. So when you're doing transform, you have the input and you have selected nodes. Okay. So let's do a filter. Tunes. Okay. The tunes are, okay. Input dot tunes dot tunes. No. Let's find out. Let's find our filter packet, filter stage, because he went through this already. Okay. He takes the packets, tunes, filters them based on something. Okay. I'm not selected. Is input dot tunes dot filter. It's included if selected elements. Maybe we need to do .tunes .enumerated. Okay. And then this is, I think it's, well, index and tune in. We want to return them when selected elements dot contains index. Okay. Is that going to be right? Okay, filter gets us result tunes, and then we're going to do this kind of thing. Return the original packet. No, that's not right. Well, it's input. We'll take that down. Okay, so he's saying return input. Let's see what this constructor does. Okay, basically this one appends the metadata. Okay, so, all right, that seems to be kind of what we're after. Result tunes. Oh, selected tunes. Okay. Do I have to make an array out of it? I think I've got my enumeration number in there still. Okay. So I've got a pair index and tune. I'm going to only keep the pairs where selected index contains the index, selected elements contains the index. Then I'm going to change the index and tune to just the tune, and that gives me an array of tunes. And that's going to work, I hope. All right, and then what I do with that is I create a new packet built from the metadata, the original, with the new tunes. All right, and I got tests failing. 2 failures. One failure. Okay, what did you get? 2. 1, 2, 3, 4, 5. Okay, let's run that again. Okay, and I'm going to stop in there. Okay, so this is the first time through. Let's see, selected tunes. Should be number number 1 and number 2, I believe. 1 and 3. Zero. It's hard to tell from the outside. Star UU. Okay, 0. Star UU. Dot count. Okay, they were the identical ones, so star UU is correct. All right, and that's that one. All right, let's continue. Come back around. Let's see. Whoa. Okay. Let's look at input. Star UU, star UD, should be star UU, and then a 4 or 5 character one. Star UD UU. Okay. Right. So we've got the matrix, we've got the cluster. Oh. Okay, that was all set last time. So let's see our selected elements. One, 4, 3. Okay. That's not right. All right. I don't think I get a chance to do it again. Why did those reset? I think I'm going to have to break here. That should just end. Okay. Let's run that again. Why? Oh. You got to actually change the stage. Stage.selection. Okay. That's got a better chance. Whoops. Has no member selected elements. Okay. We'll turn these breakpoints off. Oh my. Now what? 2 still. Okay. I'm going to break there again, I guess. All right. Let's make sure we got the right stuff going on. Okay. So mostly I want to make sure my test is doing the right thing. So he calls transform with packet. And he's got the same packet again. Those IDs should be the same. So we shouldn't execute that stuff up top first twice. Okay. So the first time through it should do this. Second time through it should not do this. All right. And run. Sorry, I got a very unhappy toddler upstairs there. Hopefully it's not coming through too loudly. All right. So first time through, step over. It should be a different ID. Okay, that's good. We'll continue. Okay, let's see the selected elements. Okay, 3, 1, 4. Really 1, 3, 4, but I guess it's a set. It doesn't matter. All right, and now selected tunes. Well, I guess I will step over this. And selected tunes should be 2 tunes. Okay. Okay. We'll continue. All right, now this time it should skip over that. Yes. Okay, so let's look at selected elements. Should be 1, 2, 3, 4, 5. Yes. Okay. And then I guess I can break inside here. Each one of those should trigger it. false. Okay, this is 0. Okay, and we'll continue. And now this should be true. The rest should be true. Two, three. Well, whoops. Okay. What happened here? Why? We had at least 3 come through, so what's the deal? Okay, so that should have picked up a bunch. All right. Packet with input. Tunes is selected tunes. Metadata. All right. Sorry. I'm gonna do this again. I guess we saw this was right. It only ran this the first time. Can I print here? If I can type it, I can do it. Print index and selected elements dot contains index. Okay, it'll break here. And I'll take this break out. Okay, I think I'm ready to run. Should stop here once. We'll let it go. Okay, you can continue and continue. And now continue. I should see. Whoa, 0, 1, 2, 3. Okay. 3 trues, 0, 1, 2, and 3. Let's print selected tunes. Count should be 3. Okay. And we'll continue. Okay, what's the matter? Output? What's output? Oh, I ignored it. Okay. Well, this one's the one that should be ignored. Helps if you look at the right output. Okay. I guess we do need that. Okay. Var output. Let's be specific. 1, 2, 2. All right. We'll delete these breakpoints. Continue. All right. Run all tests just to make sure. Okay. It's warning me these could be better. I agree. I've turned on Swift Lint, so I've got a lot of extra warnings and just trying to keep things a little extra nice. I don't like the yellow noise, so we'll get rid of that. All right. Commit that. Make cluster include only selected leaf nodes. Okay. Now the run. We'll start big. All right, add the cluster. Now I should only see those two nodes, 1 and 39, in my output. Yes. All right, if I do this, I should see all 39 nodes. Oh, okay. Oh. Yeah. All right. We're getting a lot of... Oh, no, interesting. That's only showing up once. Okay, so we have some sort of update issue. Oh, yes, of course we do. All right. In filter stage, no, filter stage here. Yeah. When you change the filter, actually that's on the view, I think. Right. Yeah, here we go. When you change the selected field, then it notifies everybody, hey, the pipeline should change. All right. So we need to do that same thing for ClusterStage. And I don't have a good way to do that independently of this environment object. Oh, and it doesn't even belong in this file. It should be a cluster view. Oh, he has environment. He has that object, but he doesn't do the changed. I think it's on the cluster controls view. Oh, it's on the text field. Okay, in our case, it's stage.selected, selected elements, or whatever we called it. Selected elements. Oh, is that going to work? It's really on this guy. Okay, so in the view, if you ever notice that the selections have changed, selected elements have changed, then you definitely need to update. Okay. I think that might be enough to do it. Selected elements are published, so they should be good. All right, let's try it again. All right, 2 elements. Hopefully 39. Yay. Okay. I mean, that looks like 39 didn't count, but this should be, I should be able to just count these. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. I believe we are cooking with gas. Should be about half. Yeah. Okay. And whether the order of these is the best order, I don't know. It might be nice to put them in the order they're in here. Can I do that? I don't think I can because it's coming out of a set. That's another topic for another day, I think. Make the selected nodes pass out through the filter. Yes, that's what we're doing. Okay. I guess my question is, can the clustered elements appear in the same order in the Parsons code? The answer today is no, because we sort them in that view, but we might be able to do that outside. Okay, I'll put this down low because I'm not sure I care that much, but all right. And then we've got a print statement in our cluster stage. All right, so this selected elements, we're running through in order, in the original order. So it's just saying, is this leaf in or not? So I don't think we have any control there. If they weren't a set, there may be another way to do it. We do have this structure, we call it connector. Okay, and it's mostly used by the drawing stuff to draw these brackets. Bracket might be a better name even. It knows the element IDs. I don't think we made them recursive in the end. Yeah. We talked about maybe doing that, though. Connectors could contain connectors, and then everything would be hooked up, and you would know which one. And same thing on the, I mean, maybe we can get it from the cluster. The cluster does know all that stuff. That might be a doable thing. All right, let's make sure we didn't break anything. Okay, remove unneeded print. Now I have unnecessary white space. Let's cancel. What's that cluster stage? The editor's supposed to deal with that. How bizarre. Reformatting, put space in. Nice. Which Swiftlet hates with burning passion. And the editor's supposed to delete it when you go from line to line. Okay, let's try that again. Commit. Okay, there's the print. Oh, and we added selection. All right. Now, I think that puts us pretty good. I want to move on to this next time. This might be closer to that. Just set it up here. Okay, when we do these clusters, well, two problems. One is I'm overwriting, the arrow is writing to the center of the bracket line, but at some point we were doing this in a certain order so it would hide it. But I really want this to just scoot over that much. And I think, well, that's kind of one thing. Fix that line in there. The second thing is I'd like these lines to be at least the distance, kind of half the diamond's distance horizontally is sort of the minimum distance I want between two nodes and, between the nodes. So this would have to scooch over a smudge, probably half that or something. I'm not sure what that's going to do to our drawings. I don't know. I'm struggled a bit on getting these drawings set up to just the right level. I wouldn't mind a little tiny bracket in front of this that was the width of this would actually be a good look, to make these, so these zeros aren't infringing on the lettering and stuff, and just kind of more obviously brackets all the way down. So we'll see what to do. The problem I have is, like, this node has 2 levels underneath it and 3 levels on this side. Okay, so when I do that node, I can't just, I've got to take into account, like, this side's got to add some here, and then does that mean we scooch this node out? I think it might. Kind of their minimum distance has to be that bracket, and if I moved it over half my node distance, I'd get them out of the diamond, which would be progress. But I don't know if doing that's enough. I may have to look at the maximum of the 2 children and see what I can do. But I definitely don't want to start that at this point. But I think it's doable. I mean, it won't reflect exactly the mathematical distance, but it'll be much more readable, I think. We can probably, dendrogram view. At some point, I hate having to click that extra time. Let's see. We did reverse things for each. I think we could say dot reversed here. Nope. Oh, I gotta do it inside. Nope. Okay, permit. Let's see. Okay, is that gonna build? It's built connectors. Does that look right? So I think what this will do is it'll populate the brackets in reverse order, so the more left ones end up on top. Yeah. Okay, so the line is getting overwritten by the diamond now. So I made sure to draw the parent first so I could overwrite their lines. But it would be better to just figure out the right numbers and do it that way. But even this is more readable than what I had. But you can still see there's little artifacts and some confusion in here. It would clarify it. Now, I had to do some shrinking to make sure it stays in the horizontal dimensions it's got, but I think we can do that. Okay, so let me take that back out, because I think it papers over a real problem that we need to fix in it. Okay, we'll stop there. So next time is tomorrow, Tuesday, 2 to 4:30 p.m. Eastern Daylight Time and 6 to 8:30 p.m. UTC. We'll pick up with this notion of fixing the drawing, and I think we'll focus on there. It'll probably take at least, I don't even want to say. If it's done tomorrow, I'll be shocked. Let's say that much. All right, well, thanks for joining today. Hope I can catch you in the future, and have a good evening. Take care. Bye-bye.